Hi everyone. Today I thought to explain about scatter diagram. Some people call this as a scatter plot also. So first we go through what is scatter diagram. I think on the screen now you can see what is the scatter diagram. A scatter plot is a type of plot or mathematical diagram using Cartesian coordinates to display value for typically two variable for a set of data. So it is simply we can understand if we want to show correlation between two parameters, we can draw the scatter diagram and we can understand what is the correlation between the considered two factors. Why we want scatter diagram? By using scatter plots, it is easy to understand the correlation. As I told, by using scatter diagram, we can easily understand the correlations between two parameters. And it will lead to the correct decision making. So based on the correlation with two different parameters, when we take the management decision, operational decisions, it will give us huge benefit because it is very easy to understand the correlation between two factors. Now, this is simple example for scatter diagram. You can see in here heights given, in here weight given. So there are five members, five people, one, two, three, four, five. That five people's height given by inches and weight given by pound. Now we have to mark these data on the Cartesian plane. Okay, you can see the uh, that classes. Okay, when 71 inches height, that person weight is 170. The person B, okay, his height is 68 inch, then the weight is 160 pound. Likewise, we can create the that data sets. Okay, then that data set we can easily mark on the Cartesian plane. This is Cartesian plane. X-axis we have taken to mark the heights. Then y-axis we have taken to mark the weight. But it doesn't matter if you want, you can take x-axis for weight, you can take y-axis for the height. That is not any issue. You can see all data points we have already marked on the Cartesian plane. Now, okay, based on the data points marked, we can draw best fit line. Okay, as example, I can draw best fit line like this. That is not any requirement to go that best fit line through all the data point, but it has to be a suitable line. It has to match to the all data points. This line called, again I am telling, best fit line. Okay, then this is the scatter plot. Very simple. We'll move to the next slide. Okay, now you can see uh, there are several types of scatter diagram. I'll explain you how we can give the names for the scatter diagram, what are the categories and everything. Okay, you think this is the Cartesian plane, this is y-axis, this is the x-axis. Okay, so x-axis may be one parameter, y-axis may be one parameter. In this moment, just I put okay, this is x, this is y, just to understand. Okay, now I am drawing best fit line. Okay, you think okay, there are some data points. Based on the data points, the best fit line is like this. This is the best fit line. Okay, now we think okay, when we consider this point, okay, that particular x-axis point is x1 or something. Just I put x1. Then that intersect point when we project into the y-axis, okay, that particular number will take y1, y1. We'll take another point also. You think this is the considered point. That particular x number is x2, x value is x2. Based on that intersection point, I am projecting that intersection point into the y-axis. Then particular y value is y1. Oh, sorry, y2. Likewise, okay, we'll take another one place also, another one point also. This is the particular x-axis, that related value x3. When I project that intersection point into the y, the particular y value is y3. Okay, now we have to understand the relationship. It is very clear. Okay, everyone know from this side to this side. Okay, I'll draw some arrow. From this side, x values increasing. That is basic theory of the graph. Okay, and also from this side to this side, y value is also increasing, because in here usually we are taking as a zero, zero value. This point is 0 point. So x value is also increasing to this direction. Y value is also increasing to this direction. Then when we go from x1 to x2, that means our x value is increased. Then parallelly, when we increase the x value, what happened to the y value also? Y also going from y1 to y2. That means it is also increasing. Further we describe x1 when move to the x3, y1 also move to the y3. That means when x increase, y value also automatically increase. That means if we draw a scatter diagram in this direction, line like this, then the correlation between x and y is positive, because when one parameter increase, other parameter also increase based on that. That means this is positive correlation. We'll discuss another one also. Again, I am drawing, okay, because I want to clearly explain you. This is the y-axis. This is the x-axis. Just I put the axis name also. This is x. This is y. Then I'll draw best fit line in this direction. This direction. Now we see what happened. Okay. I'll take particular x value, this point. This is the x value. We'll think this is x1. This is x1. Then particular y value is y1. This is y1. We'll take another point. I'm taking point here. Then I project to the x-axis. The particular value we assume x2, x2. Then related to that intersection point, when we project into y, the particular y value is y2. We'll take another point also. Okay, in here, particular x value is x3. Then when we project that intersect point into the y-axis, particular y value is y3. Now carefully see what happened. Okay, I am increasing x values. Okay, from x1 to x2, then x2 to x3. Then what happened? When we increase the x value, okay, x1 related y value is y1. When I come to the x2, related y value is y2. What happened? What y value decreasing. When I go move to x2 to x3, then y value further decrease, y2 to y3. So that means this type of scatter diagrams show the negative correlations. When one parameter increase, other parameter going to be decrease. Okay, so these type of things we call negative correlation. So in scatter diagrams, there are mainly three type of correlations. You can see these are positive correlations. Both data set increase together, X increase, then parallelly Y also increase. Then in here you can see, okay, that data points in everywhere on the Cartesian plane. It is difficult to draw the best fit line. No, you can see. Okay, if someone can draw best fit line like this, very difficult. Okay, then someone can best fit line, someone can draw like this. So it is very difficult to assume. So this kind of things we tell no correlations. But when coming to here, okay, these are, as we discuss, okay, as we discuss, negative correlations. Because one data set increase, then what happened? Other data decrease. When the X value increase, Y value going to down. So mainly there are three type of scatter plots, scatter diagrams, positive correlations on scatter diagrams, negative correlations on scatter diagram, and scatter diagram with no correlation. But within the positive also, if the all data point lie in very closely to the best fit line, it is called strong positive. Then data point little bit deeper from the best fit line, it is we call weak correlations, weak positive correlation. Likewise, there are strong negative correlations, is weak negative correlations also. These are the type of correlations. Then it is very important to understand when we come into the organization, it may be manufacturing service, whatever the organization, there are two indicators. What are those two indicators? Leading indicators and lagging indicators. What is meant by leading indicators? An indicator of performance that might predict future success. If there are any measurement points, we can consider as a KPI also. If we focus that, if that what is called parameter can change the future prediction or performance, those are called leading indicators. What is the lagging indicator? An indicator of past performance that measure how we perform. That is already past. And also, we can't change. Simply, I can say leading indicator we can change, but lagging indicator we can't change. Okay. So it we can understand from this equation much more easily. This is a mathematical equation y equal f x. Okay, x can be there are several x's. Okay, in here you can see y equal f x1, x2, x3. So please keep in your mind, we call this y dependent variable. Okay, y is a dependent variable. Then what is x? X is independent variables. Independent variables can be several variables. So we can change only the independent variable because y is dependent variable. Please understand this equation. When we change these x values, independent variables, y automatically change. So we can't do nothing on y, we can do anything on x only. So I can match, previously we discussed, okay, leading and lagging. So I can tell y is a lagging, lagging parameter because we can't do anything on that. Then I can tell independent mean leading variables factors, leading factors. So you have to keep in your mind, if you want to improve something, okay, you have to address only the leading factors, if not independent variable. We'll take some example. Y is efficiency. Y is efficiency in the manufacturing field. Then Y equal F into, there are several independent variable as example, absenteeism, absenteeism, then machine breakdown. Okay, there are a lot. Just I type few things, machine breakdown, quality issues. What are the others? Input delay. Likewise, there are a lot of independent variables. So we have to understand, if we want to improve the efficiency, it is lagging parameter, it is dependent variable. We can't do anything on the efficiency. Okay, so we have to address only the that leading factors, if not independent variables. What are those? Absenteeism, machine breakdown, quality issues, input delays. Likewise, there are a lot. So when we change these independent variable, automatically efficiency, if not that lagging parameter, dependent variable will increase. So if we want to understand the correlation, when the absenteeism high, what happened to the efficiency? When the machine breakdown less, what happened to the efficiency? When the quality issues, quality rate high, what happened to the efficiency? Then we have to consider the correlations of that dependent variable as well as independent variable. So I think you can remember, you can understand the correlation, whatever the things which we have discussed. So if we want to match the correlation, then definitely we have to go for scatter plots, scatter plots. Okay. This is some example of scatter plots drawn by considering the efficiency and DHU. DHU means damage percentage. You can see this is actually plot based on the real data by considering some organization. Okay. It is according to this shape, you can understand that is negative correlation. Negative correlation. That means when the damage percentage increase, okay, what happen? Efficiency going to be reduced. The other way, that when the damage percentage reduce, efficiency going to be increased. So this is negative, and the data very closely lies between that best fit line. It is very strong correlation. So now you can understand efficiency and the DHU. Efficiency is what? Again, I am explaining you. Efficiency is dependent variable. DHU, damage percentage, is independent variable. Then that dependent and independent variable correlation is negative strong. So if we know this concept, okay, in our organization, we can draw several what is called scatter diagram by considering several factors. Then you can understand what is the correlation between each factors. So based on that, you can take the decision. If you want to improve something, okay, if there is a negative correlation, you have to reduce the other factor. If there are any positive correlation, then you know when we increase some factor, that dependent factor also will be increased. Okay, that is the beauty of that scatter diagram. Other than that, we can use scatter diagram for the future forecasting projections also as example. Okay, I want to see, okay, you will think, okay, in damage percentage 7 to 8, we'll think, okay, it is 7.5. Then I'll draw this kind of projection line, assuming, okay, this is 7.5. Then I can predict, okay, when the damage percentage 7.5, what is the efficiency? So it is coming into this area. It may be around 56 or 57. So that is projection. Other way also we can project. Other way also we can project. Okay, we'll think when the efficiency is 65, what is the damage percentage can be? Okay, it may be 5.8 or something. It may be 5.8 or something. So by using scatter plot, we can project also. If we know one parameter, we can project what will be the next parameters. This is the beauty of scatter plots. Okay, I think now you can have proper understand about the scatter plot. Then what is the scatter plot? Why we want to draw the scatter plot? And how we can take the correlation between two factors? What are the type of scatter plots and everything? I think now you can understand. So this is very useful tool, but most of the time the people don't know this and people not use this in a what is called operational environment. But if we can use this in operational environment, you can reach a very vast level of advantages you can reach. Okay, thank you very much. I'm expecting to meet you with another video also. Thanks.